All right, we're the WebApplets team, and this is going to be our capstone presentation.
My name is Smurth.
I'm Elijah.
I'm Enrique.
And I'm Adrian.
Traditional web apps are strongly tied to their visual representations. They make very strong assumptions about how the user interacts with them. They're built and they consist of flows. Buttons need to be pressed to enable other buttons. They're just very generally state heavy. And more than that, they can't be used effectively without a pair of eyes and a mouse. This causes difficulty when interacting with machine agents and with accessibility systems. Recently, the rise of AI has actually increased the demand for machine usable systems, and web apps, traditional web apps, have begun to show their flaws more and more.
And to give a quick overview, WebApplets is a flexible and open framework developed by Ethernet. It's based around the idea of actions. So what that basically means is modular tasks that can be reused and triggered in different contexts. Sorry. What makes this powerful is that it's designed to be compatible with large language models, so LLMs. So you can command these actions using natural language. This means AI's tools can interact with web apps just like humans do. We were really curious about how this changes the role of the browser itself, and that curiosity drove our project.
For the project timeline and approach, our initial plan was of three phases. We wanted to do background research on the design and experiment with the WebApplet SDK since it was new technology that none of us had ever worked with. We wanted to design the client to be human-centered, and we did that by researching and reading from different sources that our mentor gave us. And then we wanted to develop a client prototype and our outcome. We completed the timeline with three phases, albeit with delays. And right here, on the side right here, we can see how the client looks like that our mentor is working with, and it's connected to an LLM, and you can see it's giving it different actions to do, and it's like interacting. It's like giving ChatGPT apps or tools.
All right, so these are the different technologies that we used. From our mentor, there were a couple things. First was the WebApplets SDK, which entered a stable state is while we were working on the project, and it was very cool. So we could create the different web applets. It was very well defined in terms of how to create them. We could test them with an LLM that was built in, and so we had a good time with that. It also provided us with a kernel that is in the client that you just saw. Uh, it entered alpha state right as we were working on this, so it was sort of happening simultaneously. It includes the LLM capability, so you can hook up any different type of model, and it's a robust sort of framework, so everything works. You can hook up the Apple's SDK in a certain way. It has different protocols, different actions, different resources. So sort of a very robust model that allows a lot of things, even more than what we plan to do. So we built the client with Electron application. We also use React, and we built it using Vite. And the kernel was run separately at the same time. We ran it using a very simple Node.js backend that just uses Express.js as like a web interface, and it's also running the kernel. So that's what we use for technology.
And these are our web applets. We created some of these to get used to the program itself and how they work. And these are some of the ones that we created. Smurth made blackjack. Elijah did a deck of cards. I did a Wikipedian dictionary one. Adrian did a guess number and the currencies. And we learned about how they interact with LLMs, and they're pretty easy to make. The one I created was probably like 40 lines of code, and they're like ChatGPT with hands. And right here we can see the blackjack one that Smurth made, and it's like you can see it's giving him like a tutorial of how to play blackjack, like with these texts, and it's pretty interesting.
So as far as the design process, it sort of started right at the beginning when we started with the research and started looking at different resources that sort of outline different things that we could consider. And we then dedicated a specific part of our project to a design process. We did interviews with different people about some issues that they have with the browser. I want to thank Smurf for doing those interviews. We also met with the mentor. We discussed some more ideas. We also discussed specific use cases, and so it was at that point where we decided what our client would look like, and we decided on something that was tile based. You can see on the right there was an earlier idea that we had, and we decided against it. We decided for tiles, and so we had seen a package for React where you could sort of have a mosaic, and you can use different windows. We decided to base it off of that. And so we thought of it as having different discrete workspaces. So instead of just having a bunch like 15, 20 tabs open at once, you could have a workspace you're working on a specific thing. You can have different windows that have a pretty clear purpose. You can just throw up a page here, a page there, and you would have a chat. You could also integrate different window models in the future that could have specific functionality that isn't really possible with the web browser right now. So you could have a collection of pages. You could be showing a file. You could be doing a lot of different things, but it's a very flexible idea, and we thought we could make a prototype around it pretty well. So that's what we decided to do.
Right, so for a prototype, as Adrian just mentioned, we ended up using a tile-based design. Our main motivation here was to solve the mental overhead of context switching, which is something that becomes a lot easier when we're not dealing with complex visuals like in a traditional app. We do, however, support those using a web view window. Um, our client also integrates with chat, allowing for pass-through of applet actions using Internet's kernel software. Um, and building this, I feel that we learned a lot about the ups and downs of some common desktop frameworks. Electron in particular was honestly really interesting to get to work with. And this is our MVP, and we feel that it proves the viability of our client design.
And one of the biggest things we learned was how to approach design from a user-first perspective. That meant really listening to where users struggle and then coming up with solutions based on those needs. So we're not just building for the sake of building. We also had to think about how to structure our software so that it works well with large language models. Basically, how to make interfaces and actions clear and usable for both humans and AI. And then finally, working with WebApplets, which is still a work in progress framework, was a unique challenge. Since it's constantly evolving, we had to stay flexible. APIs would change, features would break or disappear, and we had to adapt quickly. But it also meant we got to experience what it's like to build on the cutting edge and even influence how the t tools can grow. And then to wrap up, we ended up designing and prototyping a browser model that really centers AI and natural language as core interaction tools. Through this, we also created several applets that show how different tasks like playing blackjack or looking up information can become more intuitive when powered by web applets. Ultimately, we hope that our work that we did today and this entire semester helps reimagine what web browsing can look like and how it can evolve to better support both users and intelligent systems.
So thank you, everybody, and I want to give a special thanks to Rupert. He was a fantastic mentor. We never met in person, but we met pretty frequently over video chat. He was a really cool guy. So just want to give special thanks to him, and that's it for Web Applets.